Hello, in this video, you're going to learn how to solve systems of three linear equations in three variables using the elimination method. Okay. The solution to a system of three linear equations in three variables is an ordered triple, and they are x, y, and z. The solution must be a solution of all three equations, like what I am going to show you now. Okay. If the given values for x, y, z are negative 3, 2, and 4, we need to check if all these values will satisfy all these three equations. And we're going to do that. Okay, so I drew a line here. Okay, so for the first equation, I substituted negative 3 for x, and you can see it here, and then y is 2 because your y value here is 2, so then you have 2 over here, and then for z it's 4, and so I've substituted 4 over here. So if you multiply 3 to negative 3, add that to the product of 2 and 2, and then add that again to the product of 4 and 4, you will have 11. So for this equation, it's true. Okay, let's keep doing that for the next two equations. Okay, for the next equation, again, we just substitute all the values of x, y, and z that's given to you over here. Okay, so the second one also satisfy and it's true. So let's check. And then substitute it again on the third one. Okay, so then again it's true. So that means these values are the solution for this system. Okay. So here are the methods that you can use to solve the systems in three variables. You can use substitution, you can use elimination, you can use the Cramer's rule, you can use the Gauss-Jordan method, and others. Why not graphing? Okay, just like what we talked about for solving linear equation, systems of linear equation in two variables. Well, maybe graphing may be technically be used as a means to solve a system of three linear equation, but then again, it's very tedious. And also, you can use your calculator if you need be, if you want to use graphing. Okay, but we're not going to talk about that in this video. Okay. So, this lesson will focus on elimination method, and let's start with that. Okay. So let's try this example. You're given three equations and you have three variables x, y, and z. Okay. The first step will be to rewrite the system as two smaller systems, each containing two of the three equations. So we're going to do that now. Here are your three equations. Okay, so I'm showing it to you by using this line. So we're using equation 1 and equation 2, and then equation 1 and equation 3. So let's rewrite them. Okay, for equations 1 and 2, let's put them down over here on the left side, and equations 1 and 3 here at the right side. We are going to solve them separately using what you know in solving systems of linear equation in two variables, similar to it. Okay, so step 2, eliminate the same variable in each of the two smaller systems. Any variable will work, but sometimes one may be a bit easier to eliminate, so you need to use your judgment. Okay, always try to find a way that will make it easier for you when you are solving. In this case, I'm going to choose x for this system. Okay, so now I have rewritten, this is equation 1, this is equation 2, this is equation 1, and this is equation 3. Okay, now I'm going to solve this by elimination. I'm going to multiply first equation by negative 3, okay, because I would like to eliminate x. Now, if I'm eliminating x here, I should be eliminating x in here as well, okay? So now, I'm going to show you what will happen to equation 1 after I have multiplied it by negative 3. Okay, so it will become negative 3x plus 9x minus 18z equals negative 63. Now, I'm going to rewrite equation 2 down here. Okay, now because they have opposite symbol, we can just add this equation because we can now eliminate this. So negative 3x plus 3x is eliminated. 9y plus 2y is 11y. And then negative 18z minus 5z is negative 23z. Negative 63 plus negative 30 is negative 93. Okay, now I'm done with this one. I eliminated one variable. I'll do the same to the second set, equations 1 and 3. Okay, I would like to eliminate x, so I would like to have the same coefficient. I'm going to multiply this by negative 2. Okay, now the new equation 1 will be written here. After multiplying all the terms in equation 1 by negative 2, we will have negative 2x plus 6y minus 12z equals negative 42. I'm going to rewrite this equation down here, okay, and then add these two equations, and I will get y minus 10z equals negative 48. Now on the next slide, when we move, I'm just going to rewrite these two smaller equations. Okay, so step 3, write the resulting equations in two variables together as a system of equations. Then solve the system for the two remaining variables. This is what you have done in the last time. Okay, so then we have 11y. These are the results of the computation a while ago. So we need a common coefficient. So I'm going to multiply the equation here by negative 11. Okay. Okay, sorry, the negative 11 should be written down here. So then this negative 11 is multiplied to the second equation. That's why you have negative 11y plus 110z equals 528. Okay, so then add these two equations. You will get 87z equals 435, and then we're going to divide both sides by 87, and your z is equal to 5. Now that we know that z is equal to 5, we can just choose any of these two equations and we substitute the value of z by 5, okay, and I use this equation. So y minus 10 times 5 is equal to negative 48. So in this case, I use the second equation here. Okay, and then we will get y minus 50 equals negative 48, and your y is equal to 2. We now know two values of your two variables, y and z. Now, we are going to go back to the original equations and choose one from it, and we will replace z by 5 and y by 2 to get the value of x. Okay, so then step 4, substitute the value of the variables from the systems of two equations in one of the original equations with three variables. Okay, we're back to the three original ones. Just choose one from here and substitute the y and the z by the values we just solved. Okay, so I'm choosing the first equation. I put the value of y2 over here, and then 5 and that z there. Okay, and then solve it, and x is equal to -3. Take a look at it and check if I have solved the equations correctly. Okay, now at this point, I now have all the values of my x, y, z or three variables. I'm not going to stop here because I would like to check my solution. Okay, I'm taking all the values and see if they satisfy these three equations. So x -3 minus 3y, y is 2, so I replace y by 2, and z is 5. Okay, for the first one, it's correct. Okay, I'm going to check the second one. It's also correct. Okay, I'm going to choose the third one. It's also correct. So I know I have the correct solution. So the solution is x is -3, y is 2, and z is 5. Okay, at this point, okay, I am going to show you that it's important, or tell you that it's important to neatly organize your work on your paper. Okay, remember the three original ones. Choose two. You can do 1 and 2, and then equations 1 and 3. Okay, and then you solve and eliminate the same variable. Okay, once you have done that, you will have just two, and then solve those remaining just like how you solve problems in solving system of linear equation with two variables. Okay, and then you will get the two variables. Okay, and then once you do, you go back to the original equation and replace them with your two values. Okay, x, y, z. Okay, now try this one. Okay, sorry, I have shown you the answer, but in school I'm going to give you some few questions that you can try. Okay, I hope that was clear, and I'll see you in class.